Today in class you're going to be learning about the history of our Earth and fossils. Studying the rock and fossil record helps us understand Earth's history and the history of life on Earth, especially since we haven't been around for much of it, really. How old is the Earth? Well, if the Earth celebrated its birthday every million years, there would be 4,600 candles on its birthday cake. Humans have only been around long enough to light the last candle on the cake. So knowing that our Earth's history is so huge, we need a way to divide it up. So we divide it into the geologic time scale. And basically, the geologic time scale takes the 4.6 billion year history of the Earth and divides it into different sections. The largest section is called an eon. Eons are divided into eras. Eras are divided into periods, and periods are divided into epochs. You might be wondering how this geologic timescale was created. Well, scientists use two things called the rock record and the fossil record. The rock record was created by scientists making observations based on different layers of rock which are exposed in canyons. Since a canyon was rock layers that were previously there and weathered, eroded away, we can see the different layers throughout them. One of the best examples of this is the Grand Canyon. The layers there represent almost half of Earth's history. That would be about 2 billion years. Scientists use a principle called superposition to help them study the rock record. Superposition states that the oldest rocks are at the bottom and the youngest are at the top. Check out the picture of the messy locker that looks like it could be some of your lockers. At the bottom, you would find the oldest notebooks or the oldest books that were placed into that locker. And then at the top would be the most recent things or the youngest things. The rock record looks at the relative age of rocks. So to figure out how old a rock is, you can't pick it up and talk to it, or it doesn't have a sign on it saying how old it is. So scientists use relative dating, which is where they would look in the rock record and look at the layer of the rocks there to determine whether the things in that layer are younger or older than other layers. So here's an example that you can relate to. In this picture, it's quite obvious who's younger and who's older. The man on the left is definitely older. You can see he's got gray hair, he's balding, he's kind of hunched over using a cane. And the person on the right is definitely younger, more youthful, lively. So we can compare the two ages of these people to each other. We don't have to use numbers. We would just say that the person on the left is older than the person on the right. And we can do the same thing with rocks based on their layers and that whole principle of superposition. This is a picture of the rock layers and what you might see inside of a canyon. And here's another one. In this picture, you can see that the layers on the bottom in layer 1 are definitely the oldest. Those are showing fossils of a trilobite, which were around many years ago, towards the beginning of Earth's history. If you look towards the layers at the top, you can see that there are various fossils in each layer. Now, of course, as in science, there's always going to be something that changes it up a little bit. Now, we don't always have such nice rock layers as we saw in the pictures before. Sometimes there are things called rock unconformities, where the rock record is interrupted. An unconformity is when the layer or layers of rock are missing, which leaves gaps in the rock layers. A lot of times these happen because of a little force we know of as erosion. So maybe there were rock layers there before, and perhaps something like, I don't know, the Colorado River comes through and makes a big gap in the rock layers called an unconformity. So in this image, at the bottom left, there are perfect layers. You can see it says deposition, like when all the rock layers were deposited on top of each other. And then it's showing that as it goes up, there are forces like uplift and erosion that cause the layers to become shifted. And then they get deposited again, and you would have your unconformities in the rock layers. Another type of unconformity where the rock layers don't all follow the correct pattern is called an intrusion. Kind of like an intruder, like it wasn't there before. An intrusion is when molten rock or magma squeezes into the rock layers and then cools. You can see in the picture like all those layers were there before, and then that kind of blobby looking thing in the middle is where the magma came through and caused an intrusion. Alright, so we talked about the rock record. Now let's talk about fossils. Fossils are the remains or physical evidence of an organism preserved by geologic processes. Now, a lot of times these fossils are preserved in rock, and they're preserved in a type of rock we learned about known as sedimentary rock. Can you think of how sedimentary rocks are formed? Remember the 2 C's in talking about the rock cycle. When you've got all those sediments laying around, what happens to them to make the rock? Give up? Remember compaction and cementation? Ring a bell? There are a few different types of fossils. We're going to talk about just 2 of them. One being body fossils, which are the actual organism preserved itself. 2 are trace fossils, which would be any kind of naturally preserved evidence of activity. So not the fossil itself, but any evidence left behind. That could be burrows or footprints or even animal waste. So how can fossils be preserved? There's a few different ways. In rocks, like we said before, usually sedimentary rocks, they can be preserved in amber, which is tree sap. You can have petrification, like in that bottom picture, where the minerals would replace the organism's tissue. A couple other ways that fossils can be preserved are shown here on this slide. Kind of creepy, but that picture on the left shows an actual iceman that was preserved. So fossils can be frozen, and also kind of like that woolly mammoth on the right. Fossils can also be preserved in asphalt. For example, like the La Brea tar pits, which I believe was shown on the Bill Nye video. You may be wondering to yourself right now, why do I care about fossils? They're old, they're dead, they do not relate to me at all, why do I care? But they are actually very useful. They help us determine what life was like years and years and years and years ago before anyone was even living here. They tell us what the environment was like, and they kind of tell us how life has changed over time. The fossil record is just basically a rough sketch of history of life based on fossils that we study. This diagram shows how the geologic timescale was divided into the different eras and eons and epochs and periods. Go ahead and pause the slide and take a look at it for yourself. So kind of like the rock record, the fossil record can help us to determine the ages of different rocks and fossils in the layers. There are these really important fossils called index fossils, which help us determine the age of the rock because these organisms were around only for a short period of time. They are things that lived for a little while and became extinct. So if we find those things in a layer, we think, oh wow, okay, I know exactly when this time period was. For example, if you were to find a picture of Psy, you know, Psy Gangnam Style, and you saw that, you would kind of know what time period that's from because he was only popular for maybe a year or two, and that was a couple years ago. You wouldn't look at it and say, oh yeah, this is from the early 1900s. You would know that it's from like 2013 or so. Here's a real-life example of an index fossil. It's called a trilobite. Trilobites were around about 400 million years ago. So scientists know if they see those or they find those fossils in the rock layers, they know the age of all the rock around it. Now back to that geologic time scale. We're going to talk a little bit about the eras. The Paleozoic era is like the old life. Even before reptiles. The Mesozoic era is the age of reptiles, and the age that we live in, the era that mammals are part of, is called the Cenozoic era. Go ahead and take a minute and study this diagram to see the different eons and eras again.